All right, let's talk about trig functions of any angle. So you already know how to write or how to figure out the trig functions of any angle in the first quadrant. So the 30, 45, 60, you can find any of the 6 trig functions of those angles. And you know how to find the 6 trig functions of any angle from the unit circle that are multiples of 30, 45, or 60 degrees. So any of the angles that are in any of these other quadrants, anything that's on the unit circle, you can find the 6 trig functions of those angles. Well, today's concept is going to be about finding the trig functions of angles that are in other quadrants besides the first quadrant, and they can be found using what's called corresponding acute angles called reference angles. Okay, so reference angles are different depending on which quadrant you are in. By definition, the reference angle, which I'm going to call theta prime, so that little apostrophe there, I'm just going to use the word prime, is the positive acute angle formed by the terminal side and the x-axis. These things are key. Positive acute, okay? So they're always going to be less than 90 degrees, positive acute angle, and then formed by the terminal side and the x-axis. A lot of students confuse this with doing it to the y-axis. It's always going to be with the x-axis. So looking at quadrant number 1 right here, that's going to be your reference angle. In quadrant number 2, that's your reference angle. So that's between the terminal side and the x-axis. Then in quadrant 3, you've got this is your reference angle, and it's between the x-axis and the terminal side. And then in quadrant 4, your reference angle is here between the x-axis and the terminal side. So in quadrant 1, you'll notice that in the diagram, it's just labeled as theta. And that's because in quadrant 1, theta prime is the same thing as theta. The reference angle is the angle itself. Now in quadrant number 2, this would be your angle theta moving in a counterclockwise direction from the positive x-axis, but this is your reference angle. So in degrees, we know the whole thing is 180 degrees. So to find theta prime, we just need to subtract theta from 180 degrees. So theta prime would be 180 degrees minus theta. And if we were doing this in radians, it would be theta prime is pi minus theta. In quadrant 3, we have this angle here that is from the positive x-axis moving counterclockwise, and our reference angle is just this angle between the x-axis and the terminal side. So if we want just the reference angle, then we have to subtract 180 degrees from theta. So theta prime is going to be minus 180 degrees, or if we were in radians, then theta prime would be theta minus pi. Okay, so already we're seeing 2 different relationships between finding a reference angle in quadrant 2 versus finding a reference angle in quadrant 3. And finally, in quadrant 4, to find the reference angle, here's your angle overall moving counterclockwise from the positive x-axis, and then your reference angle will be this angle here. So you can probably figure out that theta prime is going to be 360 degrees minus theta, or 2 pi minus theta, if you were measuring in radians. Okay, take a minute and find the reference angle for these 2 angles. So the reference angle for number 1, you need to figure out that that's going to be in quadrant 4. Remember when we talk about quadrants, we use the capital Q and then the Roman numerals. And quadrant 4, so that's going to be 330 degrees over here. Now, you don't have to draw the picture every time you answer the question. You can just do this in your head, but I'm just writing down how I know what my answer is. I moved counterclockwise 330 degrees. And so my reference angle in this case, so theta prime, is going to be 360 degrees minus 330 degrees. So that's going to be 30 degrees. Again, you don't need to write down all these steps. You can just write down 30 degrees because you can do that in your head pretty easily. Now, for question number 2, negative 5 pi over 6, that's actually going to be in quadrant 3. Remember, 5 pi over 6 is here in quadrant 2. But negative 5 pi over 6 is moving in a clockwise direction to get there. So that's going to, let's go ahead and label that as 5 pi over 6, so negative 5 pi over 6. So that's that reference angle there that I've marked in purple. That's going to be theta prime. For theta prime, you could do the whole thing, negative pi, and subtract negative 5 pi over 6, but you would end up getting negative pi over 6, but your reference angle always has to be positive. So what I would actually do there is I would figure out that this is coterminal with 7 pi over 6, right? So negative 5 pi over 6 is coterminal with 7 pi over 6. So you can either use the unit circle to figure that out, or you can add 2 pi to negative 5 pi over 6 to get the 7 pi over 6. So then to find the reference angle, 7 pi over 6 and minus pi. So that's going to be 7 pi over 6 minus 6 pi over 6, which is going to be pi over 6. But like I said, you could have done it with negative pi, but then just do the absolute value because your reference angle is always going to be positive. All right. Number 3, find the reference angle for this one. Now, this one's a little different. This is a radian measurement, and I know that simply because there's no degree symbol. That's why it's so important for you to put degree symbols on your degree measures. So we need to figure out in which quadrant we would find 2.3 radians. Well, that's going to be in quadrant 2. I don't know exactly where it is, but I know that 3 pi is here, so 3 radians is here, and this is about 1.57 radians up there. So 2.3 radians is about, there we are, 2.3 radians. So to find theta prime, I just simply need to take pi and subtract 2 pi over 3. I'm going to get a decimal. It's approximately 0.8416. All right, now this next thing, I'm going to walk through this, but honestly, I never use this concept, but I did want to point out that if you consider an angle that's not in quadrant 1, so here I've got an angle drawn in quadrant 3, and theta would be that large angle there that's moving counterclockwise from the positive x-axis. And then this distance here, we're going to call that r, from the origin down here to that point. And that point we're calling x comma y. So over to the x distance and then down y distance. So the sine of theta, it's really the same thing as theta prime. So finding the sine of theta is really the same thing as finding the sine of theta prime, or the reference angle. So it's just going to be opposite over hypotenuse. So let me actually label, this would be x here, right? So from there to there would be x, and then y would be from there to there. So that's going to be equal to y over r. And then cosine of theta, that's adjacent over hypotenuse, so it's going to be x over r. And tangent of theta is opposite over adjacent, so it's going to be y over x. And then, of course, you can do the reciprocal to find those reciprocal functions. So cosecant of theta is going to be r over y. Secant of theta is going to be r over x. And then cotangent of theta is going to be x over y. So like I said, I don't actually use this if I'm solving the problems that we're about to do, but I did want to point that out. It tends to show up in textbooks and stuff like that. And of course, we also have this relationship, of course, that x squared plus y squared is equal to r squared because it's a right triangle. So here's the types of problems that you're going to see. It says the terminal side of theta in standard position contains the point 8 comma negative 15. We want to find the exact values of the six trig functions of the angle. So remember, don't stress out about the phrase standard position. It just means that your angle starts in the positive x-axis and moves counterclockwise. Let's draw a little picture. So 8 comma negative 15, that is going to be in quadrant 4. So I'm going to draw a ray in quadrant 4 here, okay? And then it's passing through the point 8 comma negative 15. So 8 comma negative 15. And then your angle, of course, would be that angle there, theta. And we want to find the exact values of the 6 trig functions of theta, but really you're using the reference angle theta prime. So let's drop a perpendicular here. So there's my right angle. And then I'm going to, if this is 8, negative 15, then that horizontal distance there is going to be 8. And then the vertical distance is going to be negative 15. And of course, it's not drawn to scale. It's kind of very badly drawn, actually. And then we could use a Pythagorean theorem to find the hypotenuse. So let's do that. A squared plus 15 squared equals, we can call it r squared. And working that out, you're going to end up getting 17 is r. So once you have now your hypotenuse is 17, now we can go through and say, well, then the sine of theta is opposite over hypotenuse. So negative 15 over 17. Cosine of theta adjacent over hypotenuse, so it's 8 over 17. Pause the video and do the other. All right, so you should have gotten these as your answers. And I want to point out that the sine is negative, so of course the cosecant is negative, and then the tangent is negative, and the cotangent is negative. We talked about that before, about how if you're going to be somewhere in quadrant 4, then you're going to the right, you're going down, and then the second coordinate is going to be negative. And so with the unit circle, it's cosine and then sine if you're in the unit circle, and the sine is always going to be negative there, which means that your tangent and your cosine will be positive, which means your tangent is going to be negative. So just reinforcing that idea. Let's take a look at number 5. So here we have the question is kind of very similar, but it's actually written very differently. It says, given that the sine of an angle is negative 2/3 and then the tangent of an angle is positive, we're going to find the cosine of the angle and the cotangent of the angle. So I would first figure out in which quadrant is my angle going to be. Well, if my sine is negative and my tangent is positive, that's going to put me in quadrant 3. The sine is negative if I'm going down from my y coordinate, so it's either 3 or 4, but the tangent is positive and tangent is positive in quadrant 3. So I'm going to draw my ray in quadrant 3, and I'm going to label this as theta here. You can label it theta or theta prime, it doesn't really matter. And we're going to label it, we've done problems like this before. I'm going to label it such that the sine of the angle would be -2/3. So the opposite, remember from SOHCAHTOA, sine is opposite over hypotenuse. So I'm going to take the negative with the opposite side. So we're going to call the opposite side -2 and the hypotenuse 3. And you're always going to do that. The hypotenuse is always going to be positive. And then we'll do the Pythagorean theorem to get the other leg. So we'll have basically 2 squared plus, let's call it x squared equals 3 squared. So x is going to end up being the square root of 5. So square root of 5 is there. Now, here's what's tricky. It's actually negative square root of 5 because we are going left. That's very common for students to miss that. So they just put the square root of 5 and they go on about their business and find the answers, and then they get the points off because they forgot that it's negative because you're in quadrant 3. So now we can just use SOHCAHTOA to find the cosine of theta. So it's adjacent over hypotenuse, so -√5/3. And then we can find the cotangent of theta, which is going to be adjacent over opposite. So that's going to be -√5 over -2, which of course makes it +√5/2 is a cotangent of theta. All right, and then our last example, we're given that the tangent of some angle is this -4.4623, somewhere between 0 and 360, and we want to find those angles to the nearest 1/10 of a degree. So we're doing this in degrees, which is quite nice. So what we're going to do is we're going to find the reference angle. And you do that by simply saying that the tangent of the reference angle is going to be positive 0.4623. And the reason for that is because in quadrant 1, let me back up to quadrant 1 for a second here. In quadrant 1, the angle is the reference angle. So we're trying to find the reference angle. So let's just use quadrant 1, and then we can figure out what quadrant we need to be in. We'll do in the calculator, do inverse tangent, make sure you're in degree mode, inverse tangent of positive 0.4623. So if you're in degree mode, you're going to get that the reference angle is 24.8 degrees. Okay, now here's the thing. Tangent is negative, and tangent is negative in which quadrants? It's negative in quadrants 2 and quadrant 4. Now, 24.8 degrees is not in quadrant 2, it's in quadrant 1. So we're basically saying that we have an angle, let's draw two different pictures. We have an angle in quadrant 2 whose reference angle is 24.8 degrees. And then we have another angle in quadrant 4 here whose reference angle is 24.8 degrees. And we are going to find those angles. So let's label this. This is going to be 24.8 degrees here, 24.8 degrees there. We're trying to find that angle there, theta. So let's do that one first. We'll come down here. So that means that theta is going to be 180 degrees minus 24.8 degrees, which is 155.2 degrees. So that's our angle in quadrant 2. And then in quadrant 4, this angle here is 24.8 degrees. And we are ultimately trying to find this angle here. So to do that, we're going to say that theta is going to be 360 degrees minus 24.8 degrees, and that's going to give us 335.2 degrees. And so those are our two answers.